This video is on how to interpret and understand equilibrium for GCSE and for A-level. Now, for equilibrium, there are three conditions that you need to understand. If we change them, what effect they will have on the position of the equilibrium. And that is temperature, pressure, and if you add or remove products or reactants. So let's start with pressure. The first thing you need to look at with any equilibrium that you get is the stoichiometry, which is a fancy word for the big number in front of each of the chemicals that you've got. So in this case, we can see in front of the nitrogen dioxide, we have a 2, and in front of the dinitrotetroxide, there isn't a number, which means there's an imaginary 1 there, okay? So what we're looking at here, the first question that we have to ask ourselves is how many moles of gas are there? So that's the first question that you always ask yourself when you're looking at equilibrium. How many moles of gas are there? And this is obviously the indication that it's a gas on each side of the equation. So on this side we can see we have 2 moles of gas, and on this side we've got 1 mole of gas. So the rule is, if we follow Le Chatelier's principle, which is that any change that you make to an equilibrium, the equilibrium will shift to reduce the effect of that change. If I increase the pressure, so increasing the pressure will shift this equilibrium to the right, okay? So that would be the first mark in an exam, right? Increasing pressure will shift the equilibrium to the right. In other words, it's shifting it towards the products. We're going to make more product. Y is always the second mark. So whenever you increase the pressure, it will always shift it to the side with the fewest number of gaseous moles. So it will shift to the side with the fewest or smallest number of gaseous, as in gas, moles. Okay, so you're always just looking at the big number at the front to see which direction it shifts. So if we increase the pressure, it will go to the side of the smallest number. If I decrease the pressure, it would do the opposite, and it would go to the left, to the side with a greater number of moles. So that's how we deal with pressure. The second thing we need to be able to talk about is temperature. Okay, so for temperature, we need to look at the enthalpy change for the reaction. And the secret is whether it's positive or negative. If it's negative, then that means the forward reaction along the top is exothermic. Okay, that's what we mean by negative. Okay, if it was positive, then that would mean it was endothermic. Okay, and the rule is that if the top forward direction is exothermic, the backward direction in the opposite way, that way, must be endothermic. So, it's still following Le Chatelier's principle. If we make a change to an equilibrium, the equilibrium will shift to reduce the effect of that change. So, if we increase the temperature, okay, the equilibrium will want to try and make it colder. So that is an endothermic process where heat energy is taken in from the surroundings, and therefore the surroundings become colder. So if I increase the temperature, okay, I will shift the equilibrium to the left, okay? So that would be the first mark, shift to the left. The reason why is if we increase the temperature, we always shift in the endothermic direction. If I reduce the temperature, it would do the opposite. It would go in the exothermic direction. So if I was to make this reaction colder, it would shift towards the right, and we would make more dinitrotetroxide. So those are the first two bits of equilibrium, and perhaps the most two important bits that we need to be able to deal with. What happens when we change the pressure, and what happens when we change the temperature. So if we're changing the pressure, you ask yourself how many moles of gas are on each side. If you increase the pressure, it will go to the side with the fewest number of moles. So in this case, it will shift to the right, 1 mark. Y, it will always shift to the side with the fewest number of gaseous moles. If we change the temperature, increasing the temperature will always shift the reaction in the endothermic direction. So your first point with temperature is to write on which direction is exothermic and which direction is endothermic. So that is indicated by the enthalpy change. If it's negative, it means the forward reaction is exothermic. If it's positive, the forward reaction would be endo, and the other one will be the opposite. So in this example, if we increase the temperature, we will shift the equilibrium to the left because the forward reaction is exothermic. And if we increase the temperature, we always shift in the endothermic direction. The last thing we need to be able to do is what happens if we add or take away chemicals. So very simple, right? If I am adding more nitrogen dioxide, okay, then you can see the general direction of these arrows is to the right, okay. If I was taking nitrogen dioxide away, then you can see the general direction then is to the left. So if I add more nitrogen dioxide, I will shift the equilibrium to the right. If I remove nitrogen dioxide, I'll shift it to the left. And the same for the product. So if I add more dinitrotetroxide, the general direction is I will shift it to the left. Okay, we'll try and reduce that change by making more nitrogen dioxide. If I remove more nitrogen dioxide, the general direction would be to the right. Okay, so Le Chatelier's principle, one more time, is that any change you make to an equilibrium, the equilibrium will shift to reduce the effect of that change. So if we increase the temperature, it will shift to make the reaction colder. It will shift in the endothermic direction. If we increase the pressure, it will try and alleviate that pressure by going to the side with less moles of gas, so that there's less occupying the reaction vessel. If we add more add more reactant, we'll try and make more product to remove that extra reactants that we've made. If I remove my products, my reactants will react to replace the products that I've removed. So this process you need to be able to do for each of the other examples that are on this sheet that you've been given. So you need to complete this for the other 5 examples in exactly the same way, indicating what would happen if we increase the pressure, increase the temperature. Those are the main 2 you need to focus on. You should then be aware of the if we add or remove products issue as well. But what would happen if we increase the pressure for each of these examples? What would happen if we increased the temperature in each of these examples?